So we said before that we're especially interested in talking about functions. When we're talking about inverses, we're particularly interested in talking about inverses that are themselves functions. For that, we're going to think about the relationship between being a function and being one-to-one. The inverse of a function is always a one-to-one relation because in the function, each x value shows up exactly once. We reverse those x values become the y values, and so each y value shows up exactly once. Similarly, if we have a one-to-one relation, its inverse is always a function. So when we're talking about inverses, what we're really interested in is relations that are both one-to-one and functions. In other words, we're really interested in one-to-one functions. When we have such a thing, when we have a one-to-one function, we can take a function and write its inverse also as a function. So here we have just an example, which I'm going to tell you the inverse of this relation is going to be a function. We have a function f of x equals 3x minus 1. We want to find f inverse. And our goal is to say f inverse of x equals some expression in x, right? So our goal is to be able to give the inverse in function notation. We're starting out by saying f of x is 3x minus 1. Now, we know how to find the inverse of a relation. So let's hop back over into relation notation. Typically, when we do a problem like this, we won't write down this step, we're just going to think it. But what's happening is that f is the relation consisting of all the pairs x, y, such that y equals 3x minus 1. And so f inverse is the relation consisting of all the pairs x, y, such that x equals 3y minus 1. So that gives us our inverse relation. But because this is not in the form y equals stuff with an x in it, we can't go from there directly back to function notation. First, we need to solve for y. So we're going to write this equation with x and y reversed. We'll have x equals 3y minus 1. And now our goal is to solve for y. I'm going to just switch that order. 3y minus 1 is x. Add 1 to both sides. 3y is x plus 1. Divide both sides by 3. So y is x plus 1 divided by 3. And then I'll just distribute that 3. Y is 1/3 x plus 1/3. So this equation now is equivalent to the equation we had for f inverse. So our relation f inverse is the set of pairs x, y, such that y is 1/3 x plus 1/3. Oh, but now that's the form that I need in order to be able to write function notation. All right, we have y equals some expression. That's the expression for f inverse. Our final result is going to be f inverse of x is 1/3 x plus 1/3. Now, this step right here, the one that we shifted our brain back into relation notation for, is the weird, mysterious step in finding the inverse. We usually describe this in words as switch x and y. But the reason behind this switch x and y move, behind the curtains, is that taking the inverse relation is fundamentally switching the x coordinate with the y coordinate. In practice, this side is all we'll write down in this process. We'll just make that switch x and y move, understanding that the relation notation is going on behind the curtain. In practice, then, this is going to be our procedure for finding an inverse function. Basically all the time, we make that swap x and y move, so where we go from f of x equals stuff with an x in it to x equals stuff with a y in it. Then we solve for y, and finally, we put our final result in function notation.